Good morning, everyone. So excited to have you here and kick off our first session of the Data for Gov Summit, which is building a government data science team. I think we've all been very excited to learn about artificial intelligence and machine learning, but all of that can't take place unless there are people behind the scenes making sure that it goes. So in this first session, you'll hear from Owen McCarthy, who is the applied data science lead within our public sector practice. He's going to walk you through how to build that team and make sure that you are really setting yourself up for success. Now, Owen is not here to take questions after the session. This is a recorded session, so we'll ask that you submit your questions live during this session in the chat feature, and then we'll make sure that we get those responses back to you. So you will get responses to your questions. Just make sure that you're placing them in the chat. And with that, enjoy the session.
Good morning, everyone. My name is Owen McCarthy. I'm an applied data science lead here at Civis Analytics, and today I'll be presenting on building a government analytics team. So, as everyone knows, building any team, including an analytics team, is a serious endeavor. So I want to break this into two parts. Getting started, so the roles and skills you need for your organization to really get off the ground, and getting buy-in. So once you have your team in place, ensuring that you're all set up for success. So I'll take each of these in turn and hopefully set you up well. So getting started. The first thing to keep in mind is that your analytics team, like many others, has distinct roles that benefit from specialization. Certainly not every agency, office, or government necessarily has the capacity to scale to this level immediately, but understanding the strengths of each will go a long way to allowing you to hire the best people and get the most out of your analytics program. So the project owner, generally speaking, comes from a program or policy area. They might or might not have an analytics background, but they definitely have the knowledge of a particular policy space to be able to see where analytics fit in and how to champion data-driven decision-making within the larger organization. They might either come from program management or be titled innovation officer. A lot of cities now have chief data officers. This is a common place where a project owner could really come from. And it's really important, especially for agencies or offices at the beginning of their analytical journey, that a strong project owner will really help to ensure buy-in from necessary stakeholders to be able to make the right investments necessary for success. Similar to the project owner, the project manager has a hybrid of analytical tools and more direct knowledge of the policy and program spaces in question. It is certainly valuable for the PM to have a closer understanding of the relevant data and analytical tools, but what's critical is having a good sense of how end users will interpret data concepts in tools in their day-to-day jobs. The project manager works very closely with technical folks to ensure success and buy-in from end users, which is, of course, what the ultimate goal of an analytical program is usually about. The data engineer has a distinct role, and it's somewhat new in the analytics space. Earlier, some years ago, they might have been known as a database administrator or even just a data scientist. And while the skill set does have affinities with data science, it has emerged as a core role in its own right. And like I said, this work used to be performed by data scientists. This is the stage 0 of a particular project, getting the data that would be used to train a model or populate a dashboard into the correct form. This is often challenging and time-consuming, and it sometimes occupies up to 90% of the time and effort of a particular project. But even if you don't hire a data engineer with that title, it's very important to recognize the importance of data engineering work. Legacy data systems in government were often built for many purposes except analytics. And there's usually quite a lot of engineering necessary to get data into that form that can be most useful for downstream analytics. And, when we think about an analytics program, we often think about models that predict or classify some key outcome of interest or a dashboard that really presents data in an interesting way. But to get to that point, you have to do a lot of hard work around data engineering that is really key to every single project. So data scientists are sometimes thought of exclusively as like the modeling and prediction and classification wizards, but they are a lot more than that. They build models and visualization tools that sit between back-end data architecture and front-end tools and end users. They come from many different backgrounds and don't necessarily have to have a literal degree or past job experience in data science. Software engineers are traditional programmers, and they might build and maintain the systems where data engineers and data scientists work. You'll most likely find your dedicated software engineers inside your agency's IT shop, and they often have a broader perspective than just analytics. They're often also a great resource for coding and engineering best practices so that you can make sure that your data and your code and your tools are functioning, secure, and deliver the value that you want them to deliver. So those are the roles that you should be looking for, generally speaking, in your analytics team. But how do you find them? So we can consider 3 approaches. One is training the staff you already have, hiring externally, or contracting with outside organizations. We can take each of these in turn. So in terms of training your existing staff, although educational backgrounds in computer science or statistics can be helpful for building a data science team, you do not need someone with a particular degree to be a data scientist. Most data scientists and engineers do not have a computer science background, and many come from liberal arts or social science backgrounds. Because of the explosion of interest in data science, there are academies, boot camps, and online courses where your data literate staff can take to prepare their role for their role as a data engineer or data scientist without going back to school for a full time or going to a degree granting institution that may be prohibitively expensive. Just speaking personally, I have been in this industry since 2012. The term data science was just starting to be used around then, but there were very few academic programs outside of traditional statistics and computer science. At Civis, our data scientists have degrees in mathematics, statistics, economics, political science, psychology, sociology, and even other fields like physics, biology, and linguistics. All that really matters is an interest in solving problems with data in the public sector and an interest in developing the skills and tools necessary to do that. So hiring, you of course could build your team with external talent, even though you need not only look at local universities. Of course, many universities now do have programs in analytics, data science, business intelligence. They all use slightly different terms, but they cover the same sort of fields. You could also, of course, look for graduates from those boot camps that do really try to place their graduates in jobs very, very quickly. You could also list positions with local professional networks, meetup.com, local hackathons, programming groups. What really matters is that you keep an open mind as to where your folks can come from. What you should be looking for is obviously a passion for public service and a desire to use data in service of the public good, but also a familiarity with the common tools, programming languages and tools that are used in analytics, and a desire to learn more about them. So you can also, of course, contract with an outside organization. This is obviously a very large area to consider, but on the one hand, you have consulting and technology companies. They bring the benefits of a seasoned staff and are already built technology tools that might make your key mission objectives much easier to achieve in the near term. You could also look for universities and nonprofit organizations. They're often very willing to partner with government agencies, but they may not, and they often work pro bono, but they may not reach the same scale or speed as quickly as you need. So it's important to identify at the outset what you are trying to achieve and how quickly you need to achieve it, and what, of course, budget you have to be able to build out that team. So just a couple of other key considerations for when you're building out a team. And I touched on this earlier, but data architecture and engineering have to come first. Algorithms, dashboards, reports are all built on data, and if garbage goes in, garbage comes out. You will save yourself a lot of time, heartache, and energy down the road if you invest in your data engineering and architecture early on. And you also have to consider your team structure. Data scientists work best when they are very, very close to the actual policy or program area that's being worked on. Data makes more sense when they understand how it's being collected and how it's being interpreted by end users. So they not only need to work with the other technical members of their team, like their project manager project manager or their data engineer, they also have to work very closely with the folks who actually will be using the data to make decisions or prioritize program access or whatever it might be. That is really where data scientists will do their best work. So in terms of contracting out, before you outsource your work or your team to either, again, a company or a nonprofit group, you should ask yourself some questions. Like, what languages and libraries are the outside folks using? Are they open source? This is a good way to avoid vendor lock-in, where you are obliged to continue using that particular vendor for a long time, and the costs of changing are very, very high because you have built your tools in one ecosystem that doesn't speak well with others. And obviously, you should ask, like, what other pieces of software you need to view and run the code. Also, you should ask, like, what is proprietary and what source code can you share from the analysis with the organization, because you want to know how your tools are being built to do, just for the faith that you'll be able to use them effectively, and also in case you need to do any kind of audit on it. What computing power do you need? There is a lot of agencies may not be at the scale where they can invest in an on-premise or cloud server infrastructure and still do a lot of work on their local desktop machines. And if maintaining a particular tool or retraining a particular model is very computationally expensive, that's good to know. And of course, the question is, how reliant are you on an outside entity to continue doing the work going forward? Like, can they train up your staff on how to do these tools the best way? Can they train your staff on how to write code that maintains any tools or models? This is obviously very important, and there might be benefits to hiring somebody who does everything by themselves, but you want to know that before you get started. So there are a lot of different ways to structure an analytics team. So you can consider a concentrated model where you have all of your analytics folks sitting in one team. So obviously with this, you get a lot of knowledge sharing, collaboration, less redundancy and more efficiency. And it can be an easy way to start out, just having everybody at once. The problem is, if they're a bit isolated, then there might be less end user alignment and a bit more bureaucracy in terms of, if I build tools in my silo and try to get people outside of that silo to use them, it'll obviously be very challenging. And of course, there are always competing department priorities, either from budget or initiative, that you might have to consider that would inhibit the effectiveness of this team. In terms of decentralized, what's nice about here, where you sit people, analytics staff, in multiple different agencies or offices, you can easily prioritize issue area needs and domain knowledge. You can probably get quick wins and easily have that end user alignment that I was just mentioning. The challenge is, of course, that there might be conflicting sources of truth, duplicated efforts, and it might look like to an executive as a not great use of resources to be replicating the same people and roles and tools in multiple different offices. So what we consider to be the better option is the hub and spoke. So you have a centralized analytics office that maintains all the data, all the tools, all the infrastructure, all the architecture. They themselves are the source of truth, but you also place people in different offices, have one or two analytics staff there to get all of that information and tool set from the central unit, but it'd be able to bring back the end user buy-in, the really important feedback that is necessary to make these tools most useful. This probably, I think, combines the best of both worlds. You have a lot of flexibility. It's easy to centralize goal tracking. But not to say that there aren't. This isn't perfect. There are cons. There can be some ambiguity in roles and exactly who owns what due to this sort of matrix structure. Okay, so now that's everything about how to get started with your team. Now we can talk about getting buy-in. So, building a data-driven organization requires attention to a number of different areas. The data you have access to, whether it's owned by you or whether it's owned by another office in the government. This obviously has a very practical effect on how quickly you're able to build your analytics office and what you're able to do with it. The people and processes you have to collect, clean, and transform those data, these are really, really important. So, once you, and just to say a bit on process, once you have data in place and people to use it, you really want to move quickly to setting up the processes by which you can decide who uses data in what systems and how quality assurance is maintained. The technology that can be deployed by those people in support of those processes, obviously, you need to consider what sorts of computing, storage, and memory requirements are important for whatever you're trying to do, whether that be a public-facing dashboard or just an internal-facing computing instance. So you want to align the technology you have with the goals of your office and update that over time. In terms of science, this is an extremely quickly changing field. The evolving state of methods that are available to you for analytics. This is, as I said, I started some years ago when all of the sort of algorithms that we now take for granted were still the subject mostly of either high-end PhD research in academia or at a select few technology companies, and it moves very, very fast. And so you want to keep an eye on what those methods are and how they're changing and how that can continue to support your mission. And of course, the culture of the team you are building and how it relates to the broader organization. I want to stick on this because culture is really key. Many organizations already have access to some data. Processes can be written, people can be hired, and technology can be either built or acquired. Transforming your culture to use data confidently and responsibly requires attention and work from every member of the team, but especially from leadership. Leadership sets the tone for how decisions are made with data, what performance metrics are tracked, and what investments should be made to scale the team. Leadership works with other leaders in government to break down some of those bureaucratic barriers that may exist and sort of share out the learnings and the tools that come from an analytics office so they can be most effectively used by people. Because of course, this is government works best when it works together, and having everybody working from the same set of tools and data with a shared understanding of what those data are and how those tools work is certainly an ideal worth striving for. And one thing to remember as you're starting out, no matter where you are on your journey, getting to data-driven decision making requires a lot of experimentation and iteration. This is obviously a stylized figure, but it conveys a good point. It's easy to look at your strategic analytics plan and see consistent growth, easy adoption of tools, and quick demonstrable wins, but it really rarely works that way. Successes and failures often follow each other. There are stops and starts and moments of great acceleration followed by stagnation. Don't be afraid to move quickly, experiment, recognize failures, and pivot when necessary, and know that everybody who's building an analytics office has been there before and has probably dealt with similar issues. And lastly, I want to touch on how to make the case to your colleagues inside of government about the virtues of an analytics office. So, there are a lot of different ways to do this. So you could do a budget analysis, and you could, a lot of agencies, for perfectly understandable reasons, built up different data systems or architectures in parallel to each other. And this creates a bunch of disparate and disconnected analytics, but also budget line items that don't really align, and that combining all of these into one shop could save money. You could also frame it in terms of strategic goals. You can't reach your key populations for program outreach or whatever it might be effectively without investing in research to understand the motivations and access and needs of that group. You could talk about ROI and highlight how you'll leverage successes and missteps to optimize future spend. You could talk about the necessity of data governance and security. there could be serious issues with lack of oversight or potential for PII, personally identifiable information leaks, if there's a current decentralized setup. And there's also, you could talk about democratization of data, enabling the entire organization to base strategy in data such that people who cannot write code, or either because they don't want to or don't have the time, can still use data in their decision making. And then, of course, data literacy. Include in your case this importance of having a plan to expand how everybody in your organization uses data. So how do you build literacy and drive adoption? You want to use a common language. You want to make sure everybody understands what you mean by particular kinds of data, what the data say, and what tools they use. So you want to be very clear about how data is defined and set that tone and give context early. As I mentioned before, you really want to ensure leadership buy-in. The leadership can do a lot to drive organizational change using data. And of course, we're talking about a data-driven organization. You want to define success and figure out the metrics that are being success for you and track them over time. And of course, this is a good lesson for every organization, not just analytics organizations, but every person and team learns differently and might need a different approach to using data, integrating data into their own decision-making or programs. And yeah, celebrate learning and curiosity. That's the fun part about working with data, right? Is getting to explore and figure things out. So that should be celebrated. So, and then just some challenges. Of course, there's always challenges with securing budget for people and tools and infrastructure. Making time. Like I said, this isn't, a lot of organizations need to build literacy, and there's a lot of change management that comes with that. And you have to move at the pace of your users, because getting user buy-in is absolutely critical, and you shouldn't expect that to necessarily go fast. And you want to stay on track, obviously. Start with a clear plan about what you want to achieve and when you want to achieve it and how, and then make sure that information and that research is always tied to an actionable decision. You can always build literacy and build tools to convince skeptics that this is a good way to approach an organization and policy. And then, like I said, stay open to experimentation and iteration. This is a key part of, any organization, but especially for an analytics organization. You're going to need to try a few things out and find out what works for you, best for you, because there's no one size fits all. With that, I'll say thank you very much. I'm sorry I couldn't be there to present in person, but please reach out if you have any questions about building out an analytics organization. Myself or any of my colleagues from Civis would be happy to talk to you. Thank you.